Hello everybody, and welcome to the next video of the course. In this video we will cover two topics: string variables and how do you get input from a user of your program. So not you controlling the code yourself, but you prompt somebody else for things like their age or their exam scores or something, and they give that information to the program. How do you do things like that? So the goal is just to talk about strings and some things you can do with them, and to show you the syntax for getting information from somebody else who's using your program. So let's start with strings. So let's review what we already know. You can store numbers in variables, as we've seen many times. So you can have numeric variables like that. So m is a numeric variable because its value is 5. And this pi is a numeric variable, pi, because it has the value 3.14. As we've seen though, you can also store non-numeric data, like a string of English. So if you wanted to save my name, you could just create a variable called whatever. So as always, you can control the names of variables, equals, and then in quotes, just write the English string of symbols you want. So you can use either single quotes or double quotes. So as always, I'm going to hop over to the compiler sometimes. So if I were you, I would do this along with me. But let me just put that string in here. This is a string variable. Okay, so string just means in quotes, and now it's like a string of English instead of being used as a number. So I can create my name, and then I can ask the computer to print that for me just so I know it's saving it properly. So this program runs, and it prints David McCune. Okay, so it knew what this variable was. It didn't have any issue with that. And you can use either double or single quotes. It doesn't matter in Python. So if I put single quotes there, it doesn't make any difference, right? It still outputs David McCune. Okay, so all that to say, we can have variables that store English strings of symbols if we want to, like somebody's name. By the way, something like 5 or 3.14, you can also save them as strings. So I could also come back here and have like x equals, and then in quotes, 500 or something. And then if I ask it to print that x, it will print 500. Right, there's my 500 there. When you put a number like this, notice it's green. If I take the quotes off, it's red. When it's in green like that, what that means is that the computer is treating this thing over here, whatever's inside the quotes, as a string of symbols. So even though this is 500, the number to you when you read that, the computer doesn't know it's 500, the number. The computer thinks of this as the string of symbols, 5 followed by 0 followed by 0. So if you put quotes around a number like this, the computer doesn't think of this as a number. It thinks of it almost like an English word. So you can no longer do addition or subtraction with things like this, for example. Like if you tried to say like y equals x plus 3, thinking that would be 503, it's not going to work because the computer is not thinking of this as 500. It's thinking of it as the string of symbols, 500. Okay. So anyway, that's what a string is. So let me jump back to the slides. So now I'm just going to show you several things you can do with strings. One of the most important things you can do with strings is you can access individual symbols or characters inside of a string. So like that name equals David McCune. Python is thinking of David McCune as this sequence of symbols. A capital D followed by an A, V, I, D. Space is its own character, its own symbol, an empty space character. Capital M, and so on. So the computer thinks of this string as 12 symbols, starting with the capital D and ending with the lowercase e. However, when you think about counting, like here's the first character, the second character, and so on, anytime Python counts in a positional way like this, thinking about the first, then the second, and so on, Python starts counting at 0. Okay, so capital D is not the first symbol in this string of symbols. Capital D is the 0th symbol. Okay, lowercase a is actually the first or the 1th symbol in this string. So Python is not unique in this. Many programming languages start their counting from 0. This is obnoxious. It will annoy you sometimes. I don't know what to tell you. I did not create Python. Okay. So now, since there are 12 symbols here, and the position counting starts at 0, there's a 0th position, which is occupied by a D, a 1 position occupied by an A, up to an 11th position occupied by lowercase e. So there are a total of 12 symbols, and the positions of the symbols run from 0 to 11. Okay, so if you want to access the symbol in position 0, this is the way you do it. So here's the name of my variable, and then you use square bracket notation, and then put the position inside there you want. That will be a capital D. So let me just come back over here to my compiler. So name is David McCune. So I could tell, like, hey computer, tell me what that is. Name square bracket 0. And then tell me what that is. If I run this, it just prints a D, a capital D. And why is that? Well, because capital D is the 0th symbol in this string. If I put a 2 right there, okay, so 0 is the D, 1A, 2V. So it should print a V, and there it goes. Okay, so as this slide shows here, capital D is in the 0th position, and the way you access it is like this. The name of your variable, square bracket, and then put the position inside of there. All that to say, be careful if you try asking Python to print this, name bracket 12 or name bracket 13, where name is currently this, right, my name. The positions ended at position 11. There is no position 12. There is no position 13, and so on. So if you try to tell Python to like print those for you, it won't know what you're talking about. It will give you an error. Okay, so on to the next operation we can do, length. So once you have a string variable, on the previous slide it was called name, but again, you can call it whatever you want. So you can call it myString if you want to. len, and then in parentheses the string name, so in this case myString, that tells you how many characters are in that string. So for example, consider this string. This space is space fun period. How many symbols are there in that string? How many characters? Well, let's count them. 1, 2, 3, 4. The space is 5, 6, 7, another space 8, 9, 10, 11, 12. The period is 12. Okay, so there are 12 characters there. And on this previous example here, there were also 12 characters in my name. The length is 12. So again, what's obnoxious though is that there's no position 12. You would think that lowercase e would be at position 12, but it is not. Okay, so it's obnoxious. This string has length 12, and the 12 symbols have positions from 0 to 11. Okay, so anyway, you can get the number of characters in a string if you want to. And just to confirm that, let me go back to my compiler real quick. Let me here do len name right here. So x is going to be the length of this name. If I run that, it prints 12 because there are 12 characters in this string. If I abbreviate my name to Dave, now there are 11 characters in the string. So when I run that now, I get an 11. So as you change your string, anytime you call in the length, it will record the number of symbols in that string. Okay, next, you can pick off substrings if you want to. A substring is just a little part of a string that already exists. So my string, and then in square brackets, A:B, where A and B are numbers. It's the substring of my string beginning at position A and then stopping right before position B. So for example, if we have this is fun string again, this is fun period, that's my string. My string 16, what is that? You start at position 1. So T is in position 0, H is in position 1. And then you count 1, 2, 3, 4, 5. You stop right before the 6. So you get his space I. So when you do a little command like this to pluck off a substring, the A is inclusive. You will get the symbol at position A. The B is not inclusive. Okay, you will not get the character at position B. You'll go up to B, right before B, and then you'll stop, just like in this example here. If you omit that A value to the left of the colon, it is assumed that A is 0. So if you do my string and then blank colon B, you're going to start at the beginning of the string and then go up to position B minus 1. And similarly, if you omit something to the right, that's equivalent to just starting at B and then going all the way to the end. Okay, so let me just show you a few of these here. So I'm going to do X. It's going to be name. That's the variable I already have. Let's do from 2 to 5. Like, what should that be? Okay, so D is in position 0, so 0, 1, 2. So I start at 2. V, and then E is in 3. Space is in 4, and that's where I stop, right? I don't go all the way to 5. I stop right before 5. So if I run this, notice it prints VE, and actually it's not showing it to you, but it's printing a space right there. It actually picks up that space. If I want that capital M, I have to go to position 6. So now I'd go 0, 1, 2, 3, 4, 5, and then I stop. So VE space M. Okay, well, what if I didn't have that 2 there? Now I'm just starting at the beginning of the string and going up to, but not including position 6. So Dave space M, it shows you there. And what if I put the 6 on the other side? Now I'm starting at position 6 and going all the way to the end. So C, C, U, and E, stop. So anyway, you can pick off little pieces of a string if you want to, you know. That will be useful for us later. Okay. The next thing we can do, we can add strings if we want to. So if name1 equals David and name2 is McCune, if you do name1 plus name2, the plus operation with strings just like shoves them together. So David immediately followed by a McCune. So let me just show you that here. So if I have name1 equals, let's say, Dave, and name2 equals McCune, and then I create, let me just print it straight up. I'm going to print name1 plus name2. Like, display to me what that is. It will print Dave followed by McCune, just like glommed right on there. If I wanted a space between the names, I can just put one in there like that. So name1 plus a space plus name2, and then it will print with a space right there. So you can format it if you want to, you know. So anyway, when you add strings, all you're doing is glomming them together. You can delete a substring from a string if you want to. There's no explicit way to do this. However, suppose you have a string and you decide, look, I don't want the characters and positions M through N. So like starting with the second character and ending with the sixth character, throw those out. For whatever reason, right? Just excise them, cut them out. You can't explicitly do this, but what you can do is create a new string, call it whatever you want. I called it new string. Take your original string and read it up to position M, and then add the original string starting at n plus 1. Okay, so what that does is it just ignores positions M through N in the original string. So just for example here, if my string is, quote, this is a string. If you wanted to delete characters in positions 2 through 5, so capital T is in position 0, 1, 2. Okay, so starting at this little I, 2, 3, 4, 5. So you want to delete is space I. How would you do that? Create a new string like this. Call it whatever you want, my string 2. You're going to keep from the old string up to position 2, and then keep also 6 on, and forget about 2, 3, 4, 5. So this 2 here, right, you don't read up to 2, you stop right before 2. So in this substring here, you're keeping positions 0 and 1. In this string here, you're keeping position 6 on, so you've now forgotten about positions 2, 3, 4, and 5. So if you ever want to excise substrings, cut substrings out, you can do it this way. On the other hand, if you want to insert a new string into an old string, so you have some string already and you want to put information inside of it, you can also do that. So suppose you want to place string 1 inside string 2 at a specified spot n. There isn't an explicit way to do that, but this command will do that for you. So here's string 1. That's what you want to insert into string 2. So take string 2 up to position n, and then add this new string, so put it in there, and then add string 2 from n on. So notice string 2 is entirely here. Here's string 2 up to n, Here's string 2 from in on. You've just inserted a new string right inside, and I've called the result string 3. Again, you can call things whatever you want. Okay, so let me just show you that over in the compiler. So suppose I have string 1 is like whatever. This is fun. And suppose you want to put this string in there. Space really. All right, you want to put the word really inside string 2. Doesn't matter what you call them, but let me just be consistent. You want to put string 2 inside of string 1. And where would it make sense to put that? Probably like right before the fun. Okay, so let's think about that. So 0, T is at position 0, 1, 2, 3, 4, 5, 6, 7. So right around position 7 is probably where we should put this string 2. So I'm going to print down here string 1 up to position 7, and then put in my string 2, and then put in string 1 again, but from 7 on. Let's just see what that does. So that prints, this is really fun. It put the really right in there. And notice there's 2 spaces right here because really had a space already at the end there. I put one in, and there was already a space before fun. So there's a double space here. So you can fix that if you want to or not. So anyway, all of that to say, we now can do several things with strings. Right? Just in summation here, you can figure out how many characters are in a string, how many symbols are in the string with this len command here. You can pick off substrings if you want to. You can glom strings together by string addition. You can delete a substring if you want. You can insert a new string into an old string at a specified spot if you want. Those are the 5 tasks with strings that we now have the syntax to do. Okay, so obviously we'll play around with this some in class, right? You'll get used to this as we use it. Let me conclude this video with talking about user input. So what I'm thinking about here is a user of a program oftentimes is not using the code of the program. So think about any sort of game you've played, right, on a computer. You're not dealing with like the code of the game, but you still tell the game information, like easy or hard, right? Do you want to play on easy mode or hard mode? You somehow enter that information into the computer, into your gaming console, whatever. It takes that in and does something with it inside the code, and you as the user don't have to see that. So anyway, that's what I'm thinking about here. How do you have somebody who doesn't deal with the code itself give the program information that it can use? How can the program eat in data that somebody else enters? And the way you do it is with this input command. So for example, how would you ask somebody what their name is? Okay, so suppose you're writing a program and the first thing you want from the program is to ask the user, what is your name? Here's how you would do that. You ask the question, what's your name? That's in quotes. That's inside this input command here. So what will happen is the computer will ask, what's your name? And then this input command allows you to grab an answer. Okay? Now, when you grab an answer from somebody, like their name is David McCune or whatever, when you grab it from them, like from the screen, you need a place to put it. You have to have a variable ready to take that information in. So the variable I've created here is called name, but you can call it whatever. So anyway, this name here is the variable in the code that will store the information the user gave you. So finally, what does this str stand for in this command? Str is short for string. So when you are getting information from somebody from the screen, you have to think about what kind of information are they giving you. Are they giving you a number? Are they giving you a decimal? Are they giving you an English string of symbols? What are they giving you? And if you're asking for somebody's name, presumably they are giving you a string. Right? They're not giving you a number. Right? My name is not 10, So anyway, that str is just there to make sure that what they're giving you, you're thinking of as a string when you eat it in. So let me just go here to the compiler and show you what this looks like. Okay, so the syntax is name. Again, you can use whatever variable name you want, but I've created a variable, and in they're going to give me their name. What is your name? Okay, like that. So if I run this, Notice what happens over here in the output box. It asks, what is your name? And then I can click right there. And notice it's blinking at me. That means I can type something. So I can type David and then hit enter. And what will happen is David will be stored in this variable here, in this name. So like after I get it, the program didn't do anything after that because I didn't tell it to. I can make it say things like this. So hello there. Like this. Hello there, and then print my name. So if I run this program again, what is your name? My name is David. I hit enter. Then it will print hello there and then tell me my name. So the program did indeed eat your name in, right? I'm just typing over here. So this program runs, by the way. So recall what I was saying about not dealing with the code itself. Suppose I don't even see the code, right? It's all covered up. You just hand this to one of your buddies, right? One of your buddies who knows nothing about coding can enter their name here, right? Buddy. And the program says, hello there, buddy, you know? So this is what it means to get user input. I don't need to deal with the code at all if I'm just working over here in this output box. Okay, so all that to say, you can grab somebody's name if you want to. What about their age? There's no difference in the idea here. You can still grab using the input command. It's just that an age is a number, you know, like 35 or whatever. So int here, that is short for integer. An integer is just a computer science way of saying whole number. Okay, so usually when people tell you their age, they give you a whole number. Children are the exception, right? So my daughter will tell you she's 5.5, right? 5 3/4, whatever. But most people, when they tell you their age, they just say 20, 25, whatever. So int is just reflecting the fact that you are expecting a whole number answer when you ask this question. On the other hand, if I ask you like, hey, what was the average on the exams you got in some course, you know? Like you took exam 1, exam 2, exam 3. What was the average? Well, an average, much of the time, is not a whole number, right? Averages a lot of times have fractions. So the way you deal with that is this word float in computer science. Float is just a fancy way of saying a decimal number. So int means whole number. Float means possibly whole number, you know, like 25 you can think of as 25.0 if you want to as a decimal, but maybe a decimal. So let me just show you how that goes. Okay, so now whatever. Average equals, now if I ask them what was your average on your exams, so what was your average? It would just read that in. And so now I can print things like this once I have it. So what was your average? Like maybe I did really well, 90.5. It knows what that 90.5 number was, right? It could spit it out to me. So the last thing I'll show you real quick is that once you have data like this from a user, you can start doing stuff we've done previously, like if statements. So for example, if the average value they tell you is like 90 or higher, that's pretty good. So you could tell them like, nice job, man, you know? So let me just show you that. What was your average? 92. It prints, nice, you know? So it read the 92 in as average, so average has value 92, and so right here, 92 is indeed bigger or equal to 90. If on the other hand, I tell, oh, my average is an 80 or whatever, it doesn't print anything because 80 is not bigger than or equal to 90. So it just skips over this. It doesn't do anything. Okay, so at the end of this video, you have some comfort with the syntax of strings. So inserting, deleting, things like this. And now you can grab information from the output box. You can grab information from a user who's not actually dealing with the code itself.